First, we'll write the free body diagram of each mass. So we have the force due to gravity, the friction force. We also have the normal force, Fn, of the table on the mass, and the force due to gravity of the mass. There's also the force of tension, which is the same throughout the system, because both of the masses are connected with the inextensible rope or cable. Inextensible meaning it's not stretchy. So after drawing the free body diagrams, the next step is always to write the net force equations. So we have one net force. We can write a net force for these green forces. The force of friction is opposing the force of gravity. You can see the force of gravity is pulling the system down, and the force of friction would be opposing that, pulling backwards. So when we add the two forces, we get our net force in that direction. Net force is the total mass of the system times the acceleration of the system, which is what we're solving for. And we have Fg. We know force due to gravity is always mass times gravity, which is 12 times 9.8. We could use 9.81 or sometimes even 10. Let's just use 9.81 actually. Plus our force of friction. The force of friction, we have an equation for, it's mu k times the normal force. We don't have our normal force yet, but we can get it when we do a new net force equation for just the mass on the table. So the net force of the mass on the table is the sum of the two forces. Net force is just the sum of all the forces in a particular parallel direction. The mass is not moving up or down on the table, it's just moving left-right. Since it's not moving up or down, there's no net force in this direction, so equals 0. That allows us to write an equation for the normal force in terms of the force due to gravity. It's the negative. They're opposite directions. Now we can substitute for that in our previous equation, times negative force of gravity. Now let's substitute for all the values, where we have mu k is 0.4. The total mass would be 10 kilograms plus 12 kilograms, or 22 kilograms. And negative Fg, Fg is mass times gravity. The mass of the 10 kilogram block times gravity. Notice we're using positive value for gravity throughout. Finally, we can isolate for the acceleration of the system by dividing the 22 down. Plugging this into the calculator, we should get the acceleration of the system equal to 3.6 meters per second squared. Or sometimes the units are written like this.